Hello IPX, we are here again at Embedded World 2024. We're all about disruptive technology. Now, we're about to talk about a company you've all heard of, but you wouldn't have heard about it in machine vision. Walkman, Sony. We're going to talk about Sony. This is Konstantinos from a company called Macnica, who you also probably will have not heard of. Big Japanese distributor, lots of disruptive technology on their line card, lots of interesting stuff. But today we're going to talk about Sony and machine vision and what they do. So Konstantinos, tell us all about Sony's machine vision.
Thank you guys for coming here, and thank you for being interested in our products. So what I want to show you today is how a basic machine vision system works. So I will start with the main components.
So let's just to remind ourselves, we wouldn't normally think of Sony as a machine vision company, would we?
Yes, I mean, Sony is known for many. It's a very big company. I mean, yeah. I used to have a PlayStation, so that's how I first know Sony.
Well, I'm sorry, I used to have a Walkman. There you go.
So, not many people know that are not in the industry that they have image sensors.
Exactly.
So, people in the industry, they know Sony because it's one of the most quality suppliers out there.
Right.
So they are well known in the industry,
right.
But the industry is a small cluster.
So they're taking the heritage and history of Sony, and they're taking the reliability of everything we believe to be about Sony, and now you're going to talk about machine vision.
Exactly.
Yes.
So there we see a standard camera. So a camera consists of what I call 3 or 4 parts. So at the first side, starting on this, we are seeing an item here. We need to have some lens. A sensor cannot work without a lens because you won't be able to focus. So that's you're turning on your DSLR camera, that's the focus. And then you also have a shutter. So the shutter is usually a mechanical one, which is going to allow how much light gets into the sensor. So smaller window, darker, larger window, more light gets inside. Then you have some sort of bracket. So there's a PCB that we call module sometimes in our board.
This is actually a module. So the design engineer would buy this as a module, would they?
Yes. So we call it a sensor board. So that has currently an IMX537. So that's one of the latest high-speed vision image sensors on the visible light spectrum. And what we have done here is we want to allow our customers to be able to evaluate the quality of the sensors.
Absolutely.
Without having to spend all their effort and the design teams to do that.
Right.
So we built a platform for them. We provide them with a reference design. So if they want to change the sensor or swap something around, they can do that.
Right.
Or they can just buy the ready-made thing
so
and
this
test it directly.
actually comes as a unit that they can do evaluation with.
Yes, exactly.
Right.
And they can evaluate 2 parts. They can evaluate the sensor quality, the characteristics, the noise. Noise is a very important parameter. They see how many defective pixels they are, if any.
Right.
So that's another important parameter when selecting a sensor. And they can do their optical test in their premises.
Right.
And the additional advantage of this is that we in Macnica, we have a strong collaboration with Sony. So we have receivers for their proprietary protocol that's called SLVS-EC.
Talk to the camera. Remind us of what the name of that protocol is.
It's SLVS-EC. So it's a Sony proprietary protocol. It's based on the electrical level similar to SLVS-EC, but allows higher transmission rates. So at the current released baud grade 3, it allows up to 5 Gbps per lane.
Right.
So instead of the standard, more or less maximum 1 Gbps in the standard SLVS.
Right.
Another very well-known protocol, it's MIPI, and MIPI is also available in some of the Sony sensors, but usually it's the lower speed one because it cannot reach the 5 Gbps of the SLVS-EC. So if you absolutely care about frame rate, SLVS-EC is your answer.
Okay.
So just to come back on this, so we have the photons coming in the lens, they pass through the different lenses and they hit the surface of the sensor.
Yep.
So then those are converting internally in the sensors. You have some ADCs, so you get some digital output. That data need to flow to a processing unit.
Yep.
Or a DSP.
Yep.
So what we have here is we have an intermediary board that we call FMC. and that has all the power supplies and the basic functions that are needed to operate the sensor. And we have this cable. Which,
okay, and that comes as an evaluation kit as well, does it, with this?
Yes, so they can be bought separately or bought as a package.
Okay.
And it plugs into any standard FPGA development kit. So if you it's based on a protocol, on a standard known as FMC.
Right.
So you can plug in most available development boards, or if you make your own development board based on an FPGA, you can plug it on top and use your current kit.
So this module is compatible with nearly every kind of FPGA system that you'd have sitting binding to do the DSP work.
Exactly.
Okay, good.
And that's the advantage. So we this particular board is an Altera board that we have there with Area 10 as an FPGA, but we also support Intel, and we also have solutions with Lattice. So we cover many of the FPGA players.
Okay.
And what we see on the inside of this design, it's actually our own IP. So we have the SLVS-EC receiver IP. So the sensor sends the data on that protocol, and you have to receive it on the FPGA end before you can do any processing.
Yep.
So that's the main product that we see here. It's the SLVS-EC IP that's developed by our own team. And then we need some basic processing to get from raw data to an actual picture like that we see on the screen.
Yep.
And I can actually see that we need to adjust a bit the focus.
Yep.
So there it is.
And then this scary thing comes on the screen that's been scaring the living daylights out of me ever since you've been talking. I'm thinking, what's that spooky thing that's going to creeping up on behind Konstantinos? There it is. My God, I can't look. Keep going, keep going.
Yeah, so we need raw data.
Thank God it's gone.
Raw data are not visible. You have to process them, you have to trim the data. There are many operations that has to be done, and that's why FPGA is a good platform for imaging and vision applications, because they allow the flexibility to do exactly what you want.
He's back.
Have to be fast. Yeah.
Okay, good. So, is that everything that you'd like to say about Sony's machine vision?
Yeah, I mean, that's a good example. That's what I see from customers. A typical example of a machine vision camera.
Yeah.
That's you have something you want to measure. So it could be on an industrial line. It can be boxes.
Yep.
And that's the label that you are scanning. So where it needs to go. It can be barcodes that you need to do some sorting activities.
Okay.
Or it can be.
Hurry up, because he's coming back around again. Hurry up. We've got to finish.
So, yes. You lost my train of thought.
I know, it's my fault. That's completely put you. Just talking to camera, that's absolutely fine. It's all my fault for completely putting Konstantinos off. So that's an introduction to Sony's machine vision. You probably wouldn't think of Sony as being a disruptive company. I certainly wouldn't. But would you think of them as being a machine vision company? Probably not. So Konstantinos from his company Macnica has introduced you to Sony. They've got lots of other very interesting disruptive companies which we'll be covering over time. So thank you very much, Konstantinos.
Thank you very much, Guy. It's a pleasure.
Thank you for frightening the living daylights out of me this morning, and thank you.
Thank you.
Hey, yo, where my engineers at?